quadratic formula, a fundamental tool to solving quadratic equations. The quadratic formula provides a straightforward method for finding the roots of any quadratic equation, regardless of whether it can be factored easily. It is derived from the process of completing the square, and it is widely used in algebra. The quadratic formula: if ax squared plus bx plus c is equal to 0, but a is not equal to 0, then our x is equal to negative b plus or minus the square root of b squared minus 4ac you divide by 2a. And we say that b squared minus 4ac must be greater than 0 or two real solutions. B squared minus 4ac, when it is equal to 0, we have one real solutions. B squared minus 4ac, when is less than 0, we have 0 real solutions. The objectives of this topic is that by the end of the lesson, we should be able to derive the quadratic formula from a standard quadratic equation, and using the quadratic formula to find the roots of quadratic equations, apply the quadratic formula to solve real-world problems, interpret the results obtained from the quadratic formula, including complex roots. Our references can be Mathematics and Discovering Mathematics. That is book 3. You have the discussion there, and let me now share my screen. We consider the general quadratic equation of ax squared plus bx plus c is equals to 0, where a is not equal to 0. We solve this equation using the method of completing the square, subtracting c from both sides. Ax squared plus bx is equals to negative c. When we take this c to the other side, it will become negative. We divide through by a, that is x squared plus b over ax is equals to negative c over a. We complete the square on the left hand side by adding b over 2a squared to both the sides. X squared plus b over a x plus b over 2a squared is equals to b over 2a squared minus c over a. But b over 2a squared minus c over a is equals to b squared over 4a squared minus c over a, which is equals to b squared minus 4ac over 4a squared. Therefore, x squared plus b over ax plus b over 2a squared is equals to b squared minus 4ac over 4a squared. We factor the left hand side, which gives us x plus b over 2a squared is equals to b squared minus 4ac. We divide by 4a squared. Now we take the square root of both sides. It gives us which gives x plus b over 2a is equals to the plus or negative b squared minus 4ac over 4a squared. If therefore follows that x is equals to b over 2a plus or minus the square root of b squared minus 4ac, you divide by 4a squared, our x will be negative b plus or minus the square root of b squared minus 4ac over 2a. And this is the solution to the general quadratic equation and is also known as the quadratic formula. We have an example. Use the quadratic formula to solve 2x squared minus 5x minus 3 is equals to 0. We compare this solution to the general equation, that is ax squared plus bx plus c is equals to 0. Our a will be 2, b will be negative 5, c will be negative 3. Then we substitute these values to the quadratic formula. It will be negative 5, this negative 5 plus or minus the square root of b squared. Our b squared now will be 25 minus 4 into a, that is 2, and the c, negative 3, you divide by 2a, that is 2 times 2 is equals to 4. We will get the 5 plus or minus the square root of 25 minus 8 that is minus 24. This will be 25 plus 24 will be 49. It will be 5 plus or minus the square root of 49 divided by 4. This will be 5 plus or minus 7 over 4. So our x will be 12 over 4 or negative 2 over 4, which is equals to 3 or negative half. We have an exercise there. We'll be able to do it after the lesson. And from the quadratic formula, we notice that the nature of the roots will depend on the values of b squared minus 4ac. There are three possibilities. Number one is that when b squared minus 4ac is greater than 0. Here, the value of b squared minus 4ac will be real and will take either a positive or negative value, leading to distinct root values of x. We have a second scenario where b squared minus 4ac is equal to 0. In this case, the quadratic formula will give us a single value, and the quadratic equation has repeated roots and is a perfect square. And we have the third scenario where b squared minus 4ac is less than 0. Here b squared minus 4ac will have no real values, and the quadratic equation has no real roots. The expression b squared minus 4ac is known as the discriminant. This part is known as the discriminant, and it allows us to determine the nature of the roots of a quadratic equation. Determine the nature of the roots of the following quadratic equations. We have some questions here. X squared minus 3x plus 4 is equals to 0. 2x squared minus 3x plus 1 is equals to 0. Now we move to formation of quadratic equation. We consider the following examples. Peter travels to East Angle's home 30 kilometers away from his place. He cycles for 2/3 of the journey before the bicycle developed mechanical problems and he has to push it for the rest of the journey. If his cycling speed is 10 kilometers per hour faster than his walking speed and he completes the journey in 3 hours 20 minutes, determine his cycling speed. Now we let the Peter cycling speed be x kilometers, then his walking distance will be equal to x minus 10. When you calculate the time taken for the cycling, that is 2/3 of 30, you divide by x, that is 20 over x hours. Time taken in walking will be equal to 30 minus 20 plus x minus 10. So it will be equal to 10 over x minus 10 hours. Our total time will be equal to 20 over x h plus the 10 over x minus 10 hours. So therefore, this will be equal to 3/3 hours. Then 60 into x minus 10 plus 30 into x is equal to 10x minus 10. The equation will be then x squared minus 190x plus 600. We divide them in both through the equation. Divide by 10, we'll get x squared minus 19x plus 60 is equals to 0. Then we solve it by using the quadratic formula where our b will be negative 19, our c will be 16, our a will be 1. So we substitute the quadratic formula, we get x is equals to 19 plus or minus the square root of 361 minus 240 divided by 2. Our x will be equal to 15 or 4 when you calculate it. If his cycling speed is 4 kilometers per hour, then his walking speed is 4 minus 10 kilometers, which gives us a negative 6 kilometers per hour. Thus, 4 is not a realistic answer to this solution. Therefore, his cycling speed is 15. Example number 9. A positive 2-digit number is such that the product of the digits is 24. When the digits are reversed, the number formed is greater than the original number by 18. We have been told to find the number. Our solution, we let the ones digit of the number be y and the tens digit be x. Then xy will be equal to 24. That will form our number 1 equation. When the number is reversed, the ones digit is x and the 10th digit is y. Therefore, 10y plus x minus then x plus y is equals to 18. So 9y minus 9x will be equal to 18. Y minus x is equals to 2. So y is equals to x plus 2. This will form our next equation. We substitute the second equation in equation 1. It will give us x into x plus 2 is equals to 24. This will be x squared plus 2x minus 24 is equals to 0. X will be equal to, we solve it using the quadratic formula, will be equal to x negative 2 plus or minus the square root of 4 plus 96. We divide by 2. Our x will be equal to 4 or negative 6. Since the required number is positive, x is equals to 4 and y is equals to 4 plus 2, which is equals to 6. Therefore, the number is 46. We have some exercise here which you can take it other the lesson. Thank you.